Hello everyone, myself Purva Joshi, Assistant Professor at LJ Institute of Engineering and Technology. Today we are going to study few more topics of multiple integrals. So let's begin with the first topic, that is change of order of integration. Sometimes evaluation of double integral becomes easier by changing the order of integration. To change the order of integration, first we have to draw the region of integration with the help of given limit. Okay, then we draw a vertical or a horizontal strip as per the required order of integration, and this change of order also change the limit of integration. So for example, here we have given, that is integration over a region R fx y dx dy. This is given. Okay, so what we have to do, firstly we have to draw this region R, okay, with the help of this given limit. Then we have to decide that we have to draw a vertical strip or a horizontal strip. Okay, and if in question the vertical strip is given, then you have to convert it to horizontal strip, and if horizontal strip is given, then you have to convert it to vertical strip. Okay, so this order will change, so it will become integration over a region R fx y dy dx. Okay, and then we will evaluate integration using this. Now let's begin with the example. Change the order of integration and evaluate integration 0 to infinite x to infinite e raised to minus y upon x dy dx. Okay, so let's begin with the solution. Here we have x, right? So it is the limit of y. So limit of y is given in the question, that is y is equal to x to y equals to infinite, right? And the next, this is now the limit of x. Okay, so this is the limit of x, that is x is equal to 0 to x is equals to infinite, right? So here we can see that this x varies from x is equal to 0 to infinite, and this y varies from y is equal to x to infinite. Right, now we will draw the graph using these lines. So firstly we will draw this x is equal to 0. Okay, so this is your y-axis, that is x is equal to 0. Next, x tends to infinite, so we cannot draw this. So this is your portion when x tends to infinite, this portion. Okay, and then we will draw this y is equal to x. Okay, so this is your line y is equal to x, and y tends to infinite, so this is your y tends to infinite portion. Okay, so now all the lines combines at here. Okay, so this is our region R. Okay, now in the question here we have limit of y, so this is the vertical strip is given in the question. Okay, now what we will do, we will make a horizontal strip PQ. Okay, so by changing the order of integration, here we have the new strip, that is horizontal strip PQ. Okay, now you can see this horizontal strip PQ, it starts from where? It starts from here, x is equal to 0, right? And it ends at q, and this is y is equal to x. Okay, and now we are taking horizontal strip, so firstly we will write limit of x. Okay, from this only. So limit of x is what? X is equal to 0 to x is equal to y. Okay, you have to make x as a subject. So now the limit of y. Okay, so we are taking this horizontal strip, so limit of y will be from 0 to infinite. Okay, so limit of y is from y is equal to 0 to y equals to infinite, right? So from this new limit, what we can say, this x varies from 0 to y, and this y varies from 0 to infinite. Okay, now we will write the integration. So this is given in the question, that is integration 0 to infinite, integration x to infinite, e raised to minus y upon y dy dx. And now we will write the new limit. Okay, so we have variable here, so we will write it inside. So 0 to y, and here 0 to infinite. Okay, this is the function e raised to minus y upon y, and previously we had dy dx, so now we will write dx dy. Okay, so this is our new integration after changing the order. Okay, now we will evaluate first with respect to x, keeping y constant. Okay, so you will get integration 0 to infinite. This y constant, so e raised to minus y upon y take outside. So what remains? Integration 0 to y dx and dy as it is. Okay, now if we will evaluate this integration, so integration of 1 dx is what? X. Other terms will remain as it is. Okay, now just substitute the limit, so you will get y minus 0. Okay, so y minus 0, that is y, so this y will get cancelled, so what remains is integration 0 to infinite e raised to minus y dy. Okay, now we will evaluate this integration, so you will get e raised to minus y upon minus 1. We will use this formula, that is e raised to ax dx is what? E raised to ax upon a. Now here our a is minus, so upon minus 1, and thus minus we will write it in the numerator. So minus e raised to minus y, and the limit is 0 to infinite. Okay, now we will substitute the limit and we will take this minus out. So you will get minus e raised to minus infinite minus e raised to 0. Okay, now e raised to minus infinite, that is 1 upon e raised to infinite, and e raised to infinite is what? Infinite. So here we have 1 upon infinite, and that is 0. So the answer of this term is 0, and e raised to 0 is what? 1. So minus minus will become plus. So the final answer of this integration after changing the order of integration is what? 1. Okay, now let's begin with the another example. Change the order of integration and evaluate integration 0 to a y to a x upon x square plus y square dx dy. Okay, so here y is given, right? So firstly we will write limit of x. Okay, so limit of x is given, that is x is equal to y to x is equal to a. Okay, so now next we have to write, that is limit of y from this, that is y is equal to 0 to y is equal to a. Okay, so you can see this x varies from what? X is equal to y to x is equal to a from this, and y varies from y is equal to 0 to y is equal to a. Okay, so using this we will draw graph. So firstly we will draw this line, that is x is equal to y. Okay, this is our line, x is equal to y. Next we will draw x is equal to a. So this is your line, x is equal to a. Okay, and next y is equal to 0 means this x-axis, this is y is equal to 0, and y is equal to a. This is the line somewhere here. This is the line y is equal to a. Okay, now firstly we have the point of intersection at this point. Okay, so this is the intersection point of y is equal to a and x is equal to y. So y is equal to a and x is equal to y. Okay, so in place of y, if you will substitute a, so you will get answer of x as a. So we have the point a comma a. So this is our point of intersection. Now the region is this portion. Okay, because it consists of all the given lines. Now here in the question limit of x is given. So horizontal strip is given in the question. Okay, so what we have to do? We have to make a vertical strip. Okay, so we will make a vertical strip and we will change the order of integration. So you will get here a vertical strip PQ, right? Now we will write that this vertical strip, it starts from, this is our new strip. Okay, so it starts from here, y is equals to 0. Okay, and it ends at where? This line y is equal to x. Okay, now we have this vertical strip. So firstly we will write limit of y from this statement only. So from this, taking y as a subject, so you will get y is equal to 0 to y is equal to x. Okay, and now what remains is limit of x. Okay, so we have this vertical strip. So just move this strip. So limit of x is what? From 0 to a. Okay, so limit of x will be x is equal to 0 to x is equal to a. Okay, so you can say that x varies from 0 to a and y varies from 0 to x. Now we will write the integration, that is given in the question. This is integration 0 to a y to a x upon x square plus y square dx dy, and this is equals to, now we have changed the order. Okay, so here we have d by dx, and to write the limit, now you can see here we have variable here, so we will write it inside, that is integration 0 to x, and the constant 0 to a we will write outside. Okay, now we will evaluate this integration firstly with respect to y, keeping x as a constant. Okay, so this x we will take outside, so what remains is integration 1 upon x square plus y square, right? Now this x is constant and we have to integrate with respect to y, so we will use this formula, that is 1 upon x tan inverse y upon x, right? The formula. So you will get here 1 upon x tan inverse y upon x, and the limits are 0 to x. Substitute the limit, okay, and we will cancel this x. So what you will get, integration 0 to a. This x upon x, that is 1. So tan inverse 1 minus, substitute 0. So you will get tan inverse 0. Now we know the answer of tan inverse 1, that is pi by 4, and tan inverse 0 is 0. Take pi by 4 outside of the integration, so you will get pi by 4 into integration 0 to a dx. Now integrate this, so what you will get, pi by 4 into x, and the limits are 0 to a, right? Substitute the limit, so you will get a minus 0, that is a. So the final answer of this integration after changing the order of integration is what, pi a upon 4, right? So in today's session what we have studied is to change the order of integration, right? So for that, suppose in the question if it is given f of x y dx dy, okay, so firstly what we'll do, we will draw this region R and we'll check whether the vertical strip is given in the question or the horizontal strip is given, okay, and then we will change the strip and we will change the order. So you will get this double integration f of x y, next you will get here dy dx over region R, and we will evaluate this integration to get the answer of given question. So I hope you have understood throughout the session. Thank you for watching.